Hey everybody, welcome. Day 3 of reInvent. How's everybody doing? Good. Hey, so my name is Becky Weiss. I am an AWS engineer. Back home in Virginia, I work on virtual private cloud, VPC, your virtual data center in the cloud. So we're going to talk about, in this hour, how to do networking in AWS. Now, as with everything in AWS, you are here at reInvent representing a very wide spectrum of background when it comes to networking. On one end of the spectrum are those of you who have deep experience in the realm of networking. How many of you consider yourselves to be networking people? Yeah, a lot of you. And those of you who have been deep in this field, you know that it's a lot of work. This is a hard job, right? You need to be an expert in all of the things that make a network work. Routing, firewalling, basic network services like DNS. You need to be able to configure them so that they do what you intend. And then there is the ongoing forever tax of maintaining it, right? People love to blame the network, right? So you need to keep this thing working all the time, and they expect it to be working all the time. So it is constant, high maintenance, high touch work to keep it running. And then at the end of the day, after you have done all of that, you don't always have the visibility that you want. Is this network actually doing for you what you want it to do? And if you make a change, what's going to happen? So for those of you from this deep technical background in networking, you're going to find that VPC, your network in AWS, gives you a lot of these controls, in some cases more control, but with a lot more flexibility, a lot more visibility, and pretty close to zero maintenance. So you get to have the control without the drudgery. Now, on the other end of the spectrum are those of you who the whole reason you are in the cloud, the whole reason you're in AWS, that you're here at reInvent, is networking is, you need it, but it's not exactly the kind of thing you want to get too involved with. Right? The way you provide value, your business provides value to your customers is not by networking, it's by whatever you provide to them. So yes, you need connectivity, you need security, but you don't want to spend a lot of time on that. And VPC does this heavy lifting for you. And for those of you approaching networking in AWS from this angle, my goal here is in the first half of this talk, in the first 25 minutes, to give you really everything you need to know to be productive with your network in AWS. It really is that simple, even if you don't come from a networking background, to get your basic connectivity and security. Now, those of you who are here who are experts in VPC, you've been using it a long time, you know all its features, you know all its ins and outs, you've come to the wrong place. This is an introduction. We're going to do kind of a grand tour of everything that VPC has to offer you, and I'm going to show you different places you can look for places to kind of extend that knowledge after you go home. So let's start at the beginning. EC2, Elastic Compute Cloud. This is AWS's virtual machines in the cloud. If you're in AWS, it's very likely you're deploying applications on EC2. Now, of course, the E in EC2 is for Elastic, which means you're probably going to have multiple of these. And Elastic means you're going to scale up as you need more, you're going to scale down as you need less. You know, that's the whole promise of AWS here. Now, of course, these are virtual machines. They're not sitting under your desk, so they're in our network. They're in our data centers around the world. They're in our network. But the thing is, in AWS, they are in your network. They are in a VPC. This is your network. You own this network, and you control it. So what are the kinds of things that a network does for you? Well, IP addresses, that's an important part of a network. So your VPC does that for you and gives you some control over that. You can divide up your networks into different subnetworks. We'll talk later about what this means for building high availability applications, because that high availability is actually a very important feature of your VPC. Routing, right? Your packets need to go somewhere, so your VPC does routing for you, but in a way that's pretty easy to understand and know what's going on. All right, so what are we going to do here? What's our agenda here? In the first half of this talk, we're going to get familiar with the basic anatomy of a VPC. And the easiest way to learn about this is with an example. So we're going to walk through step by step. We're going to set up kind of the most basic VPC, actually a VPC that will probably suit many of your needs just fine. So we'll walk through a basic VPC setup step by step. That'll take us about 25 minutes, and then you'll know everything you need to know. And the second half of this is the and beyond part. I'm going to show you all the other lots of other kinds of connectivity with VPC, how your VPC interplays with the rest of the AWS services. So let's get started on this basic VPC. And when I say basic, the most basic VPC out there is a VPC that has connectivity to the internet. This is often what you want. And as a matter of fact, those of you who have accounts that you've created since 2013, you already have a VPC in your account. You may have seen it. It's called a default VPC, and it's set up pretty much exactly like we're about to do here. If it suits your needs, you should use it. But it still behooves you to understand its anatomy so that you can make full use of it to get all of the connectivity and security features out of it that you need. 4 easy steps here. I'm going to talk about IP addresses. We're going to talk about high availability and what your network in AWS has to do with that. We'll talk about routing, because of course it's a network. And then we'll talk about security. All right, first, a network needs IP addresses. And in VPC, you get to choose it. Now, a little refresher. Those of you from a networking background, this notation is going to be old hat. We use this notation throughout the VPC product. I'm going to use it throughout this talk. If it's unfamiliar to you, this is CIDR notation. CIDR stands for Classless Inter-Domain Routing. And it is a notation for ranges of IP addresses. So what you see here looks like an IPv4 address followed by a slash followed by a number. And the way to read that is you write out that IP address as a 32-bit number, which it is. The /16 means fix the high 16 bits, and the low 16 bits can vary. So in English, what you're looking at over here is 172.31.something.something. It's all of the IP addresses in that range. And you know what? That's a good choice of address for our VPC. So let's choose that. Now, how did I get there? You have your choice of IP address range for your network. So why did I choose this one? Well, first of all, those of you familiar with this will notice that I chose an RFC 1918 range here. RFC 1918 is an RFC that reserves certain IP address ranges for use by private networks. And the P in VPC is a private network. I have a private network here. Let me use private-looking IP address ranges. Now, you don't have to use an RFC 1918 range, but unless you have a really good reason not to, I strongly recommend that you do. And the reason why is you'll just be following convention. Anybody who knows something about networking, looking at your IP addresses, they'll see the IP addresses. They'll know these are addresses in a private network, which is correct. So follow convention if you can. Your life will probably be a lot easier. /16. You get your choice of size for your VPC. I chose /16, which gives me 65,000 IP addresses to play with in my VPC. Now, that might sound like a really big number to you. It doesn't cost anything to make it that big. It might sound like a really big number. You might probably not going to be using all those addresses, though on behalf of AWS, I sure hope you do. But the reason to make your VPC nice and big from the get-go is it gives you plenty of space and flexibility to grow in the future. So you might be only running a couple resources, a couple hosts in there to get started. That's fine. This gives you the flexibility to grow. And the only other thing to think about, in the second half of this talk, we're going to be looking at all of the other networks. VPC gives you some good connectivity features to connect to other networks. You probably want to avoid overlapping with those ranges if you can anticipate other networks that you might connect to. So we've chosen an IP address range. We're going to have IP addresses. Next, let's talk about subnets or subnetworks. Now, the reason why I bring this up is that this is very closely related in AWS to high availability, specifically giving you the tools to be able to deploy high availability applications in AWS. Who here cares about high availability? Yeah, I sure do. All right, so your VPC lives in one of our 14 global regions. Your VPC is a regional network for your resources in that region. For this example, we'll use the Dublin region, EU West 1, but similar is true in any of our other global regions. So your VPC spans the entire region in theory. But each of our regions is divided into multiple availability zones. Dublin has 3, EU West 1A, 1B, 1C. And what availability zones are, why they matter to you, is availability zones are specifically designed by us to have separate failure characteristics. Separate power, separate network, geographic distance. They are designed to fail separately from each other, so that if you are looking to deploy a high availability application, your best practice here is to deploy across multiple availability zones. So that when there's a problem in one, your application is still working because you're deployed across the availability zones that were not affected. So bringing this back to a VPC, in my VPC, I want it to span all of the availability zones in the region so I can deploy highly available applications. So here's how you do this with VPC. A subnetwork in your VPC is a sub-range of your IP address space into which you can launch EC2 instances and other resources. So I want to be able to use all 3 availability zones in Dublin. So I put a subnet in EU West 1A with addresses 172.31.0. something, EU West 1B, 172.31.1. something, and you get the picture. I've got 3 subnets, 3 places to launch my instances. I can build a high availability application on this. So a couple more words on that. Remember, we made a nice big VPC/16. Our subnets, you'll notice, were quite a bit smaller. They were /24. /24 gives you 251 IP addresses to play with. Now, those of you here who are really good at math, you'll notice that I didn't say 256, which is what 2 to the 8th is. We reserve 5 IP addresses, the low 4 and the high IP address out of every subnet. So your subnets are still, depending on your point of view, relatively big. You can always create more subnets. We've put one in each availability zone so that I can use all of my availability zones. But one thing to notice here, this is a best practice, unless you have a reason to do otherwise, make your VPC big, and there's plenty of blank space in my VPC around these subnets. I can create more subnets later. I've got plenty of blank space to do that. So this /16/24, all the availability zones, RFC 1918 ranges, this is sort of a best practice for setting up addressing and subnets in your VPC. Great, we've got addresses, but we want to send packets, right? And this brings us to the core concept of the VPC, the core concept of any network, really, which is routing. And routing in a VPC is done with a route table. A route table in a VPC is easy to read. It's a simple list of rules that explain packets trying to go to these destinations need to be sent to that gateway. That's really all it says. We'll look at it on the next slide. It's easy to read. Your VPC comes with what's called a default route table. These are the routes that apply to your entire network, and we'll talk about this in the second half, kind of more advanced half of this session, you can override it on a subnet by subnet basis. Sometimes you'll want to. But let's go to that default route table in my VPC and look at what it's made of. Right now, it came with just one rule. This rule, if you read it, you can probably make out what it's trying to say. If a packet's going to 172.31/16, those are addresses in my VPC, then it should get routed local. So a packet trying to go somewhere in my VPC should get routed locally, which makes sense. Now, the way routing works in a VPC, if a packet's trying to go somewhere and there's no rule that matches it, there's no route that matches it, then the packet has nowhere to go, and it gets dropped. So right now, think about what would happen if you tried to send a packet to the internet right now. Well, that internet address is going to be outside my RFC 1918 range. There's no route for it. The packet gets dropped. This is a party in my VPC, and nobody's invited. I want to be able to get packets to the internet. So what I need is something more. I need an internet gateway, a gateway to the internet. So this is something you create. You attach it to your VPC. It's somewhere you send packets when they're trying to go to the internet. That's all there is to it. Back to my route table, I'm writing a route here that says 0/0. That's CIDR notation for match everything. It's a default route. 0/0, send it to the internet gateway. Now, the way routing works in a VPC, you'll sometimes see these rules in different orders. It doesn't matter. The most specific route that matches your packet is the one that applies. So regardless of what order you see this, if the packet's going to your VPC, it'll use the local route. Anywhere else, to the internet gateway, to the internet. And that's all there is to it. Of course, you're sending packets to and from the internet, so your next question is probably about, okay, what are my tools for network security? I don't want every packet from the internet. There's a lot of stuff going on the internet. I don't want all of it, right? We give you some very good, very precise, powerful, but simple tools in your VPC to be able to control exactly what packets you can and cannot receive. There's two different concepts in VPC that help you do this: network ACLs, network access control lists, and security groups. By far, security groups are the most commonly used. You're almost certainly going to be using security groups. I'll cover network ACLs first because they're a little bit simpler. They're a blunt tool. For those of you from a networking background, if you have stateless firewalls in your data center today, network ACLs are the analog of that in VPC. It is like the route table. You get a default one for your VPC. You can override it on a subnet by subnet basis. If you look at it, this is what it comes with by default, and I'm actually not going to change this for my basic VPC here. But if you look at it, it reads a little bit like IP tables, if you're familiar with that. There's a set of rules. They get applied in order. As soon as your packet matches a rule, that's your verdict. So if you look at what I have on these rules here, you can see I'm going to allow all of the packets, which is what I want. I'm not going to use network ACLs here. But you can, and now you know about it. There's a set of rules for ingress, incoming packets. There's a set of rules for egress, outgoing packets. These are stateless, which means that you need to have an allow rule on both sides of the flow in order for your packet to get to and from where it's going. And now you know about these. These are your blunt instruments for allowing or disallowing certain ranges of addresses. So we're allowing all traffic in here, but I want to talk a little bit more about security groups, because every well-architected application in AWS has security groups kind of as part of the architecture. Let me explain with an example. I'm going to give you a very sort of simple, facile example of an application here. Let's say I have this application. It's got some public-facing web servers. These web servers, I want everyone on the internet to be able to make HTTP requests to them. So I want them open to the internet on TCP port 80 for HTTP requests, because I want everybody to hit my service. Now, in the course of handling one of these requests, these hosts will go turn around, make a request to some kind of back-end service that I'm running on these blue instances. They're running some back-end service on some arbitrary port, let's say 2345. And they expect traffic from the web servers, but really no one else on no other ports. So what did I just describe here? So I have two groups of instances as far as network security needs go, right? I have the group of web servers, so let's call that the web servers security group. I have a group of backends, let's call it the backend security group. And different rules should apply to them. For the web servers, I want to allow the web traffic from everywhere. And for the backends, I only want to allow that other group. So that's what I want to do in English. Here's how you model that in a security group. So for the web servers, you'll see that I have a rule here. You can probably understand what this rule is trying to do. HTTP traffic, TCP port 80, allow it from everywhere. Now, I'm not allowing other ports. I'm not allowing other protocols. I don't want the internet to have SSH access to my host, so I don't have port 22 open here, just port 80. And I'll mention that these are, unlike the network ACLs, for those of you from a networking background, these are stateful rules. And what that means, these are inbound rules. You can also do outbound rules. I'm not showing them. They're less commonly used. These are inbound rules, and the security group rules govern what happens to when someone tries to initiate the connection. So when someone tries to initiate a TCP port 80 connection to me, these rules are stateful, they track the connection, the reply packet is allowed automatically. I don't need a rule specifically for the reply packet. And that's usually what you want. So these are about the SYN packet of your TCP connection. So this is doing what I want, but let's go look at the backends, because that one's a little more interesting. You notice here, let's say 2345 is the port that my application is running on. You notice here in that source field, I don't have a range of IP addresses or a laundry list of IP addresses. I have another security group, right? And think about how flexible this is, right? If you've ever tried to work with firewalls yourselves, you know that you really have two choices here. You can either just allow a range and just cope with the fact that there are holes in that range that aren't actually assigned to the host that you intend. Or you can try to manage some kind of laundry list of IP addresses that you're going to allow in. But that has some operational maintenance challenges, right? Because you're going to be elastic here. Those web servers are scaling up, they're scaling down, it's always different hosts. This is a zero maintenance way to do that. The right hosts, if they're a member of the web server security group, they're allowed in. You're not keeping track of who's who and who's up and who's down and who just added a host. This exactly expresses your security intents in your VPC, and you don't have to do any maintenance on it. So a few more words on security groups before we move on. How many of you have heard of the principle of least privilege? It's a security concept. It really means that you should give access to who needs it and nobody else. When you're architecting your application in AWS, think about who needs to talk to whom, write your security groups that way, and don't give permission to anybody else. And that's how you follow the principle of least privilege on your network using our zero maintenance tools to do that. I showed you inbound rules for security groups. Those are usually going to be what you use. But if you're trying to follow the principle of least privilege and limit what kinds of connections your hosts can themselves initiate, you want to look at these outbound security group rules. They work the same except in the other direction. And then finally, we're not going to talk about AWS's identity and access management IAM service here today. But it is definitely, as you're architecting your secure applications on AWS, definitely look into the concept of IAM roles. IAM roles are kind of a credential-less way to give your EC2 instances and other AWS resources specifically scoped permissions for what they can do. So your IAM role is what your instance can do. The security group memberships is who it can talk to. And you can see as you're thinking about security in the cloud, these are often going to find themselves in a one-to-one relationship, what you can do and who you can talk to. So that's just a tip as you're building your application, with security baked in from the get-go, which you should do. All right, hey, so if you have made it this far, you can go home and you know everything you need to know to use if you need an internet-connected VPC in AWS, you know everything you need to know to be fully effective with it. You can be secure, you have the connectivity that you need, and it's not going to take a lot of work. So if you've made it this far, you've got the basics down. We're going to spend the rest of our time here, though, talking about additional features. Your VPC does a lot more than what we just described. I'm going to take you through some of these features. I'm going to tell you in which cases these features might apply to you. And these will give you, a lot of these are more advanced concepts. These will kind of give you pointers into where you can learn more after you go home or while you're here this week even. So let's go, your VPC there was internet connected, and you can build a perfectly secure application using security groups on an internet connected VPC. That is 100% secure, but sometimes you have reasons to have connectivity beyond or in addition to internet connectivity. So we're going to talk about a few ways of doing that. First, let's talk about restricting your internet connectivity. So go back to that application, right? We had web servers, we had backends, they had different security needs, they were in different security groups. You should always do it that way. But some of you work in situations where you're either subject to a compliance regime that maybe requires you to prove that some parts of your application are actually not routable from the internet. So you need to meet some sort of compliance requirement that way. Or you're just looking to take a belt suspenders and mitten clips approach to security. Either way, we give you a way to take parts of your VPC, or in fact all of your VPC, off the internet. So in addition to the security groups, which I'm not going to show you here, let's go back to that concept of subnets. Let's put these hosts in different subnets. Now, as you remember, the subnet lives in an availability zone, so I'm really only showing you one availability zone here. I should be showing you 3 copies of this, but that's too much on the slide. So I'm going to put these in different subnets. Now that they're in different subnets, I can put different route tables on the different subnets. Up here, I've got web servers. I explicitly want these to be reachable to and from the internet. So let me put a route table on there that has a route to my internet gateway. But over here, the backends, I don't actually have a reason for them to be communicating with the internet. So why don't I put a route table on them that has no route to the internet gateway? Our documentation will call this a private subnet and a public subnet. So you'll see those words. The word public subnet, there's actually nothing public about it. Security groups work. If you are not allowing traffic from the internet, it's not going to get there. But that is what we call it. So let me draw your private subnet and your public subnet side by side here instead of one on top of the other. So, this is your setup here. Left-hand side, private subnet, no route to the internet. Right-hand side, public subnet, route to the internet. Now, you will often find yourselves in situations where, although that private subnet is private, in the sense that you don't want it to have public IP addresses, you don't want the internet being able to reach it, they do need some outbound-only internet access. Like you can imagine a host that needs to reach out to a Yum repo to download an update itself. Now, the way you traditionally do this in networking is with a concept called network address translation, NAT. You have some device that's doing connection tracking that nats everything behind one or a few IP addresses. And VPC will, and that is usually something that you have to manage and maintain. VPC does this for you in a zero maintenance way. It's fairly simple. It's called a NAT gateway. Has the word gateway, so you should think route. And that's what it is. If I want outbound only internet access from that private subnet, then I create a NAT gateway in my public subnet. That's a NAT gateway. It has a single public IP address on it. And I have a 0/0 route, a default route, saying that in the private subnet, if I'm trying to send a packet to the internet, what it's going to do, that's my route, what it's going to do is it's going to get taken to the NAT gateway. It's going to get taken to the NAT gateway. The source IP address is going to get rewritten with that public IP address, 54.161.0.39. That's how NAT works. Packet's going to go where it needs to go. The reply packet will come back, and the NAT gateway has been tracking the connection for you, so it's able to rewrite the destination IP address to wherever it's supposed to go in the private subnet. And all of this is done for you. Now, I've had customers ask me, with internet gateways, with NAT gateways, with our other gateways, what are these things? Are they routers? Is it a single point of failure? Is it a thing? No, it's not a thing. Well, it is a thing. It's a highly available, elastic, managed thing. We manage it for you. These gateways, they are not single points of failure. We manage these things for you. They just work. And importantly, they are not something that you need to worry about as you're thinking about the availability of your application. These are managed and they just work, both the NAT gateway and the internet gateway. Okay, so we have internet access from only the parts of our VPC that we want, but you might have multiple VPCs that need to communicate between each other, and you don't necessarily want to putting them on the internet is one option, but maybe you don't want to do that. A common scenario here that if you work for a larger enterprise that's looking at having several AWS accounts. Now, you might be looking at several AWS accounts if, for example, you want different departments to get billed separately for their AWS usage. That's a common scenario. Different accounts means different VPCs, but it is often the case when you're in a situation like this that there are some shared services across your enterprise that different different departments need to get to. Usually it's not cost effective to replicate it into each and every VPC, or not practical. So you want a network of shared services that you want all of these other networks to be able to reach, privately and securely. So that's where VPC peering comes in. VPC peering is two VPCs with non-overlapping IP address ranges that get almost conjoined. They have full network connectivity between the two VPCs. Now, and one other thing that is supported by peered VPCs is, you remember how you were able to use security groups being a nice cloudy tool for network security. You'd have one security group allow in a different security group. This works across peerings as well. So how you set up a peering, just really quickly, a peering doesn't exist until both sides say OK to it. So orange side will initiate the request, blue side will accept the request, and then finally there's a peering. But of course, your packets don't go anywhere without a route, so let's go add that route. PCX stands for peering connection. It's a gateway. So orange VPC, when a packet's trying to get to 10.55. something, it matches this route. It goes to the peering gateway. It goes to blue VPC, and your security groups work. Now you're probably noticing that there's a route in this route table that we haven't talked about yet, and that's the one that says VGW, Virtual Gateway. So let's talk about that one next. The VGW, the Virtual Gateway, is your tool for when you have a corporate data center, on-premises network, that you need to connect securely and privately to your VPC. And I should mention as a point of history that this functionality, being able to connect your network in AWS to your on-premises network through a private and secure connection, was in fact the genesis of the VPC product. So EC2, Elastic Compute Cloud, has existed since 2006. It existed before VPC. There was EC2 before there was VPC. It still exists today. It's called EC2 Classic. EC2 Classic is EC2 without a VPC. Older accounts may still be, older accounts are still using it. What it is it's EC2 without a VPC. So you launch your EC2 instance. Your EC2 instance isn't in a VPC. It's in a flat network owned by us. It's the EC2 Classic network. It's on the 10. Address range. So the network is ours, so we give you your virtual machine. We give you a private IP, a 10. Private IP address. You get a choice between internet connectivity and internet connectivity, so you get internet connectivity. And you get security groups, but the network isn't yours, right? And as EC2 was getting going, we had enterprise customers looking at it, really wanting to migrate applications to it, except for one problem. Their on-premises network was a 10. And it conflicted with the EC2 Classic network. In other words, they wanted to control the network on both sides. And that is where the VPC product was born. Now, we've done a ton of stuff with it since then, but that's really where it came from. So these two technologies, virtual private network and direct connect, are how you connect to an on-premises network. And it looks like this. Left-hand side is on-prem, right-hand side is AWS. VPN, these are two different services that achieve the same end through different means. I'm going to talk a little bit about VPN and just concepts you need to know. Now, this is a concept, this is a whole concept in and of itself. We have several talks on it throughout the week, so I'm just going to give you sort of the terminology, things you need to know about if you're going to be trying to set up a VPN into your VPC. So in your on-premises network, you're going to have something that we call a customer gateway. This is a network device. This is your own equipment that you run in your data center that you manage with a static, publicly routable IP address that you tell us. So it's a VPN connection, so you're going to get encrypted IPsec tunnels. That's your end of the tunnels. We have instructions in our documentation for setting up a wide variety of customer gateways, range of vendors and models with detailed instructions for each. But you set this up, and what you get is a VPN connection to our side, which is the virtual gateway. The virtual gateway is our end of the VPN connection. If you set it up correctly, you get 2 encrypted IPsec tunnels. And As a point of interest, if you're thinking about high availability, on our side, we terminate those two tunnels in two different availability zones. So that's us using our own high availability story in our network to give you a highly available VPN connection. And then the rest of this is done with a route. In your VPC, if your packet is trying to get to your on-premises range, let's say it's 192.168, you have a route to the virtual gateway, and it goes over the VPN to on-prem. And those are sort of the basic concepts. There's, of course, more to it than that. I mentioned VPN, but there's also AWS Direct Connect. And really the difference between, they achieve the same end, different means. VPN goes over the internet and encrypted, it's IPsec, it's encrypted over the internet. Direct Connect is what it sounds like. It's a direct connection, cable running from your equipment to ours in one of our many co-location centers around the world. Which one you use really depends on your data transfer needs. If you're going to be transferring a lot of data, you're probably going to come out ahead on cost with a direct connect. Higher port speeds, lower per gig rate, but higher port hour. For VPN, the reverse is true. If your data transfer needs are relatively smaller, you're probably more cost effective with a VPN. And we see customers use both, with a direct connect with a redundant VPN for the highest availability for this connection. So we've gotten between your VPC and all kinds of other places. And I want to spend what time remains here talking about how VPC interplays with the rest of AWS. Because I'm going to go out on a limb here and guess that most of you are not in AWS, not in reInvent, to focus necessarily on networking. You're using the network in AWS as a means to an end. You're here in AWS because of the breadth of services that we offer to you. Now, your VPC interplays with these services in some useful ways. So I want to take you on a very quick tour of some of the touch points between VPC and other services that you may be using, that you may be interested in using. We'll talk, some of the AWS services, in fact, can run inside your VPC. I'll tell you about how that works. We have a special setup, a special gateway for being able to reach Amazon S3, where your data might be. We let you take some control of DNS. I'll show you how you do that. And we also give you some great visibility tools in CloudWatch logs. So let's go through these concepts. AWS services in your VPC. You see that I have a bunch of AWS icons over here. There are several AWS services that, in fact, can run inside your VPC. Now, what do I mean by that? I'm going to use RDS, Relational Database Service, as an example here, although there are multiple other AWS services that work this way. Application Load Balancer, Redshift, Elasticache, Directory Service. Lots of services work this way. Let's talk about RDS. When you set up an RDS database, you'll notice that you get a chance to run it inside your VPC. And what that means is that your RDS database is actually running at an address in your VPC. Now, what does that mean? That means you get your network least privilege tools, your security groups, and you can use them directly on your database. So for example, I might have this security group of instances in my VPC that I intend to be able to reach the database. Maybe the rest of my VPC doesn't need to reach the database. I know exactly who's going to be talking to the database. So because the RDS database is in my VPC, I get to put it in a security group in my VPC and use the security tools in VPC to allow one of these security groups into the other. This is exactly what I want in terms of connectivity. Now, when you set up an RDS database, you'll get the option to do a multi-AZ deployment. That's for high availability. Those of you who know something about databases, you'll get a master database and a standby, so that if there's a problem with the master, it can fail over to the other one. RDS will use availability zones to put the master and the standby in different availability zones for the reasons that you think. And what's great about this is they're both already in the right security groups, right? If RDS needs to fail you over to your standby, your connectivity still works. The way you've set this up expresses exactly what kind of connectivity that you need, and completely hands-off, it works. Another thing I'll point out is when you run an RDS database in your VPC, it'll come with a DNS name that works inside your VPC that your instances will be able to reach it at. And there are other AWS services that work this way. I'll show you as an example AWS Lambda. How many of you here use Lambda? It's a great service. It's our serverless, bring your code, run functions in the cloud. Well, Lambda actually gives you the option to run in your VPC too. So as those of you who are familiar with Lambda know that it's a fairly simple setup. You bring your code, and Lambda runs it for you. When you run a Lambda in your VPC, that code is running inside your network. And what does that mean? If you have your Lambda function in your VPC, it can be a member of a security group, so you can give it access to exactly what it needs in your VPC without having to put anything on the internet. Hey, let's say it needs to query a database in your VPC, no problem. I set up my security groups so that they work. A few best practices here. AWS services, you'll see, when you're setting them up, you'll see that they run in your VPC. Always think about security groups. They're part of your application, and security groups should be part of your application. So always use security groups with them, and think about exactly who should be able to access them on the network level. And a lot of them will give you multi-availability zone options. Those are always the more highly available ones. It's always that service using our network's availability zones to give you the highest availability version of whatever it is that you're doing with that service. But S3, Amazon S3, is a special case here. And we have done something special here to give you private and secure and lockdown and least privilege access to your data in S3. Here's a very common scenario. You're running an application in a VPC, and your application's data, which is part of your application, is over there in an S3 bucket, or S3 buckets. Now, S3, of course, if you take the DNS name s3.amazonaws.com, it resolves to a publicly routable IP address. S3 is on the internet. So, typically you would have to put an internet gateway on your VPC, and that's how you'd get to your data in S3. But we've taken that kind of a step further. Because let's say some parts of this VPC are private subnets. You didn't want them to have a route to an internet gateway, but their data is nevertheless in S3. So what we've given you is a gateway that is specifically for S3. We call this thing a VPC endpoint for S3. But what it really is a gateway that is, you can see what this looks like. It looks a little bit different than the other gateway routes in your route table. But you can kind of reason out what it's trying to do here. If I'm trying to get to S3, the target's going to be this VPC endpoint gateway. So it's a gateway that's specifically to S3, no internet access needed, and in fact some nice properties here. Your VPC endpoint, for those of you familiar with IAM, Identity and Access Management, the VPC endpoint itself can be given IAM policies that restrict what your VPC can do in S3. So if you want a restriction on what what anybody in your network is allowed to do in S3, maybe you only want them to read and you don't want them to write, maybe you want to restrict them only to a particular bucket or a particular path in a bucket, you can put policy on the VPC endpoint to limit exactly what your VPC can do in S3. And on the other side, you can also write IAM policy on the S3 bucket. Now, why would you do this? You would do this if you had an S3 bucket that really belonged as part of the VPC. So you can make it so that only the VPC endpoint can reach this S3 bucket. So what you've done with this policy on both sides is you have your data in your S3 bucket. It's really part of your application, and you really want that bucket to be kind of part of your network. And what you've done with this policy is you've really brought your data almost into your VPC as part of your network. So this is the VPC endpoint for S3. Now, going back inside your network, one very basic service of a network is domain name resolution, DNS. Now, VPC does this for you. There's two options on the VPC to which you will probably say yes. The first one is, should Amazon do DNS resolution for you? You can run your own DNS in the VPC. The vast majority of you will choose to have us do it for you. So we'll do DNS resolution for you. Also, you generally want to say yes to this. Should your EC2 instances get DNS names generated by AWS? But if you do that, you can actually take, and you're using Amazon-provided DNS, you actually get the keys to taking even greater control of how DNS names resolve in your VPC without operating a lick of DNS machinery. So what I'm showing you here is Route 53. Route 53 is Amazon's DNS service. Over in Route 53, you can create something called a private hosted zone. Private hosted zone lets you take over a zone in your VPC. Here, in this example here, I'm showing you demohostedzone.org. You don't have to own the domain. I don't own that domain name. You can take over that domain name and be DNS god in your VPC. You can see what I'm doing here. I'm creating an A record here so that example.demohostedzone.org, I'm telling it what it should resolve to. Again, I'm not operating a lick of DNS machinery, but I'm getting to create DNS records that work in my VPC. And again, this is just something you turn off, hands-free, zero maintenance. One final interplay with AWS services that I want to point out is visibility, right? You know, as an engineer, being able to see the effects of what I do is very, very important to me, and I'm going to guess that it's important to you too. We have this feature of VPC. It's called VPC flow logs, which if you turn it on, and I'll show you how easy it is to turn it on. If you turn it on, it gives you a full dump of all of the metadata, so source IP and port, destination IP and port protocol, aggregated on a 10-minute basis. All of the data, even all the data you're accepting and all of the data that your security groups are rejecting, all of it in a single place that you can go and look at it. Now, it is probably easy to think of why you might want to do this. There's troubleshooting, there's debugging. From a security perspective, there's auditing, monitoring, making sure the traffic is kind of what you expect. There's all kinds of analysis that you can do on VPC flow logs. And boy, it's really easy to turn on. In the VPC console, there's a button, Create Flow Log. Now, those of you who have done something similar in a traditional network, you know that you need something running on the host to collect the data, you need something out there to aggregate it, you need some sort of system from which you can retrieve this information and analyze it. This is pressing a button, and you can see everything that's going on in your VPC. And in fact, let me show you what you see if you turn on VPC flow logs, just to give you an example of what you can get here. Your eyes were probably drawn to that one, weren't they? Yeah, we humans, we're interested in who gets rejected. We don't care who gets accepted, right? So over here, I've got it. You see there's actually a lot of accept traffic here, but I'm seeing that my security groups rejected something. So what is this telling me? OK, it says reject. Over here, it's telling me that somebody is trying to hit my host on UDP port 53. Many of you know that that's DNS. Somebody is trying to see if I'm running a DNS server on this host, which I'm not. And my security groups do not allow this kind of traffic, and that's why it got rejected. So who is this? OK, I can go do a reverse DNS on that IP address. That's who it is, internetpolice.columbia. And so you can see what you're getting here, right? You can see what you're getting, and you can see what you're not getting. And for those of you who are curious, if you're looking at the accept packets, this is the pattern that you would see. The flow logs I'm showing you here are from an EC2 instance that was sitting behind an application load balancer with an application running on port 8080. So you can see that there's a lot of traffic between it and another address in my VPC on port 8080. And that's legit, right? I want my load balancer to be able to hit this instance. So that's correct traffic. My security groups are allowing it. So you see a lot of accepts there. So to wrap up, you know, what have we just talked about in this last hour? We've talked about your network for your resources in AWS, how to do networking in AWS. We talked about high availability and availability zones and all of the AWS services that applies to. We talked about security, being able to easily see and change who can talk to whom in a very low maintenance way. We talked about being able to see everything that's going on, seeing the effect of these security groups with VPC flow logs. We've also talked about all kinds of connectivity. Most of you will be doing connectivity to the internet, but there's also connectivity to your data center with VPN and Direct Connect, connectivity to other VPCs by way of VPC peering, connectivity specifically to S3 with all of the controls around that. And all of this is to give you a network that is visible, flexible, zero maintenance, and entirely under your control. Thank you very much. We got some evaluations here. I would love if you filled those out. And a couple of other sessions that I have called out here that are pertinent to networking. If you are curious, all these things that I described, if you're curious to get a look under the hood, how this actually works, a little bit later today, there's a talk, NET201, Another Day, Another Billion Packets. It's an advanced level talk, but we show you how all of this actually works. Okay? Thank you very much. Have a great rest of reInvent. Bye.